The most capable reasoning AI systems in the world are largely locked away. They cost billions of dollars to train, and developers have to pay expensive API subscription fees just to access their outputs. And if you want to use those models to build autonomous agents, you run into the thinking tax. Feed a standard model a massive 1 million token prompt, like an entire software codebase, and its memory consumption explodes. The processing speed slows to a crawl. NVIDIA's Nemotron 3 Super is a 120 billion parameter model designed to solve this. It matches the reasoning accuracy of the best closed models, but it runs up to 7 times faster. Alongside the model weights, NVIDIA published the full 51-page technical report and the exact training datasets, making the entire system transparent. This proves you no longer have to choose between a fast model and a smart one. To see how they achieved this, we need to look at 4 specific engineering tricks hidden inside the architecture.
Trick number 1, the math shortcut. AI processing relies on massive mathematical equations. Normally, if you try to compress those numbers to save computing space, the rounding errors compound and the model outputs complete nonsense. NVIDIA bypassed this by training the model natively in a highly compressed 4-bit floating point format called NVFP4, starting directly from the first day of training. NVFP4 works by identifying the most sensitive mathematical calculations and protecting them at high precision. Meanwhile, it aggressively compresses the vast majority of the routine data into smaller blocks. The result is a massive speedup that preserves the model's accuracy. Trick number 2, the memory fix. Standard transformer models suffer from context explosion. To generate a new word, they have to constantly reread the entire document, which creates a severe memory bottleneck. Nemotron replaces most of those traditional layers with Mamba layers. Mamba reads a document linearly, only once. It takes highly compressed mathematical notes and discards all the filler text, keeping its memory footprint incredibly small. But to make sure the model doesn't lose precise details, NVIDIA interleaved a few standard transformer layers as anchors. These drop in to secure critical facts, ensuring the model can still find a single exact needle hidden in its compressed notes. Combining 4-bit math compression with this hybrid Mamba memory is exactly how Nemotron can hold 1 million tokens in its active memory without crashing the server. Trick number 3, the efficiency hack. Nemotron has 120 billion total parameters, but it uses a mixture-of-experts architecture. It only activates 12 billion parameters per word, which drastically saves on compute power. The standard problem with mixture-of-experts is the traffic jam. Trying to route every single word from the massive main model to the specific expert neural networks creates a severe computational bottleneck. NVIDIA's workaround is Latent MOE. Before routing decisions are made, the token data is projected into a much smaller, compressed space. Because this data is physically lighter, the model can afford to call 4 times as many expert specialists for the exact same computational cost. Finally, trick number 4, the output speedup, or multi-token prediction. Most AI systems generate their answers agonizingly slowly, calculating 1 single word at a time. Nemotron's multi-token prediction calculates up to 7 future words simultaneously in a single forward pass. It verifies them in parallel and drops the entire chunk into the sequence at once, acting like built-in speculative decoding. This chart plots the output tokens per second against median user latency. The yellow line shows the model using multi-token prediction, demonstrating a massive increase in total output throughput for users generating long sequences, like software code. Latent MO and multi-token prediction work together as a high-performance transmission. The AI thinks deeply, but outputs its complex reasoning at speeds that make real-world deployment practical. Stacking these 4 architectural innovations turns Nemotron 3 Super into a high-capacity reasoning engine specifically optimized for long-running autonomous agents. An agent powered by Nemotron can ingest endless streams of cybersecurity logs or massive software codebases and independently reason through multi-step problems without racking up a giant cloud computing bill. This pipeline diagram outlines the intense multi-agent simulation loop NVIDIA used to train the model. NVIDIA provides the specific reinforcement learning recipes and specialized datasets required to replicate their results. Solo developers and massive enterprises no longer have to rely exclusively on secretive frontier models. They now have the exact blueprint to deploy deeply intelligent, highly efficient agents onto their own hardware. AI is moving beyond basic conversational assistance to performing independent, complex tasks.
Subscribe to our channel for more deep dives into the engineering driving the future of artificial intelligence.